if we know that force equals mass times acceleration, how do we know what the force is? Well, there are lots of different kinds of force. So one common type is pushing or pulling. So this, for example, if you have an object, somebody pulls with force P, this kind of force is typically given in the problem. Another type of force is gravitational. An object of mass m is pulled with an acceleration g, and so the force is mg, that is gravitational force. Acceleration due to gravity is different on different planets, but on Earth, we use 9.81 meters per second squared, or 32.2 feet per second squared. Then, kind of along with gravity, if there's something in the way, then that creates a normal force. So let's say we have a block on a flat surface. There's a force from that surface pushing up on the block. Or if the block is on a slanted surface, there's a normal force from that surface still pushing onto the block. Otherwise, the block would move into the surface, and it doesn't. It moves along it. Now this, let's say the surface is at an angle of theta. This normal force is equal to the weight, mg, times cosine of the angle. In this case, that angle is 0, cosine of 0 is 1, so n equals mg. If normal force equals the weight. Another type of force is a spring force. So let's say we have a block here. It's connected by a spring. Spring has a constant K and an initial length, L initial. So this is the unstretched link. And then the spring force from the spring equals K times L minus L initial. Spring constant, which this is a constant value, K will be given in the problem. And then L is the current length and L initial is the unstretched length. So if the spring's not stretched, it's not making a force. If you think about it, like a rubber band, if you're just holding the rubber band, then there's not really a force from it. But if you stretch it, then you can feel it pulling back on your fingers. There's a force. The harder you pull the rubber band, the farther it stretches, the stronger that force is. Same thing with resistance bands that you use for working out. The K in the thicker bands is higher, so the force that you have to use to stretch the band is higher. Or if you use the weak bands, then the K will be very low, and the force that it takes to stretch them is also very low. Another type of force is centripetal force. So this is when object is moving in a circle. The centripetal force pulls it out of the circle. And then usually there's tension, say from a rope or something, pulling it in. The centripetal force, Fc, equals m v squared over r. So from the center of the circle, that distance is r, and v is the velocity. This tension could be coming from a string. Usually tension is something that you solve for. So either it's a force from a string here, or let's say this block was connected to another block. You could have tension in that string. And then finally, let's see, we have a friction force. So if something is on a bumpy surface, let's say surface is bumpy like this, it's got a coefficient of friction, mu. This coefficient of friction is a measure of how much the two surfaces stick together. So how do the molecules from one surface mix into the molecules on the other surface? If they mix a lot and it's very sticky, mu is high. If they don't mix at all, then mu is low. So usually coefficient is between 0 and 1. You can look these up for different surfaces. There are also two types of friction. Static and kinetic. Sometimes kinetic is also referred to as dynamic. So we'll have mu s, this will be mu k, or in some cases you might see it written as mu d for dynamic. Static friction is the object is not moving. Acceleration equals 0. For kinetic, acceleration does not equal 0. The object is moving. And static also, generally velocity is 0. And the friction force opposes the motion. So let's say velocity is going this way. Well, the friction force is going to go against it. So we know the coefficient, but how do we get the force from the coefficient? Well, friction force is just the coefficient times the normal force. So static friction force would be mu s times n. Kinetic friction force would be mu k times n. So a lot of times you might not know if something is moving or not. Say a problem might give you an object with a bunch of different forces on it and say, find the acceleration. For that, you need to first check static to see if the forces are enough to make the object move. If they are enough to overcome that static friction, then to find the acceleration, you will use kinetic. And then the last types of force we'll look at is drag force. This is force that is proportional to velocity. So let's say you have an object, the wind is blowing at it, or it could be water or something, but it doesn't really matter. Blowing at it with some velocity v, and let's say it's got an area A. The drag force equals 1/2 rho CD v squared A, where CD is the drag coefficient. Rho is the density of the fluid. So density of air, density of water, whatever that fluid is pushing. V is the relative velocity of the fluid to the air. fluid to the object. So if the object is being still and the fluid is pushing at it, it would be velocity of fluid. If the fluid is still, for example, like if you have an object sitting in water and you try to push the object through the water, it would be velocity of the object. But then if both things are moving, then you use that relative velocity. And A is the frontal area. So whatever area is facing the fluid, you use those dimensions. Drag force is something that you would only take into account if you are not using the particle approximation. So if size and shape matter, you will need this. That's for rigid body motion, which we'll get into in a couple weeks. So just keep this force formula in mind because we'll use it eventually.